All right, in part C, we need to find the exact value of the sine of 17 pi over 12. Remember, exact means no decimals in the answer. Yes, I've been checking myself on the calculator, which is going to spit out a decimal, but the answer has to be in exact form. Okay? All right, we've got another radian measure. Okay, and that can kind of be a pain to figure out what I need to add up or subtract. Okay, so let's focus on the angle 17 pi over 12. Okay, so let's think about it this way. 17 is kind of a big numerator, 17 pi. I'm going to make my denominators be 12, okay, because I'm trying to add or subtract two things. So if you're adding or subtracting fractions, you have to have a common denominator. We want the common denominator to be 12. So we've done a lot of adding. Let's think subtracting, especially because that 17 is big. Maybe we can subtract two things to get 17, okay? So let me think. We're thinking unit circle. What is on the unit circle? So like I said, just try to come up with two numbers that add or subtract to be 17 pi, okay? I'm going to do 20 pi minus 3 pi, okay? Will that work? That's kind of like the first thing that came to my mind, okay? Again, you don't have to be subtracting, okay? You could be adding, okay? We've just added in the previous examples. I'm trying to show you use of another formula, okay? I don't even know if this works. Let's figure this out. 20 pi over 12, what will that reduce to? That is going to be, let's say 2 goes into 20 10 times. Actually, I can go smaller. 4 goes into both of these numbers. Okay, so this 4 goes into 25 times, and then 4 goes into 12 3 times. So that's going to be 5 pi over 3 minus, and then 3 pi over 12 reduces to be pi over 4. Okay, so if I do 5 pi over 3, that's the same thing as 20 pi over 12. And I subtract pi over 4, which is the same thing as 3 pi over 12. When I do the subtraction, I'll keep the same denominator, which is 12. Subtract across the top, 20 pi minus 3 pi, that's 17 pi. Okay, so this is how I can compute 17 pi over 12. And if I look at the unit circle, both of these angles are on the unit circle. Okay, let me erase this stuff. I have 5 pi over 3. That is right here. Okay, and I also have the other angle, which is pi over 4. Okay, we keep using pi over 4. It's very popular when doing this. Okay, so we know that that's there because we've used it already. Okay, so those are the angles we need. Let's go ahead and apply the identity here. Okay, so we want the sine of 17 pi over 12. This is going to be the sine of, we're rewriting the 17 pi over 12 as 5 pi over 3 minus pi over 4. The order matters because when you subtract things, you know, you have to subtract in a certain order. Okay, so it does need to be 5 pi over 3 minus pi over 4 in that order. Okay. All right, so now I've got to match this up with the formula. Okay, I've got the sine of something minus something. Okay, so if I go to my formula page, if I go to page 1, okay, we need our difference formula for sine. Okay, that's going to be formula number 4. Okay, so I need to go ahead and write this down. Okay, so my formula is going to be sine of the quantity a minus b. This is going to be the sine of a times the cosine of b minus the cosine of a times the sine of b. That's what we have to apply here. Okay, so here we go. All right, this is going to be the sine of 5 pi over 3 minus pi over 4. You match up these left sides of the equal sign. We're going to get that our a value here is 5 pi over 3 and our b value is pi over 4. Okay, something I want to make sure you see is that b is positive. Okay, it is not a negative angle. You should not be writing down that b is negative pi over 4. The subtraction sign is taken care of by the formula. Okay, so they both need to be positive angles here. Okay, all right, so let's plug this in. This is going to be the sine of 5 pi over 3 times the cosine of pi over 4 minus the cosine of 5 pi over 3 times the sine of pi over 4. Okay, I'm going to continue this up here. Okay, let's go get these values. Okay, so if I look at the unit circle, okay, here is 5 pi over 3. Here's the point. So I get that the cosine of 5 pi over 3 is 1/2 the x-coordinate. The sine of 5 pi over 3 is negative square root of 3 over 2. Okay, signs are important here. Okay, we've already looked at pi over 4. Okay, so we know that the cosine and the sine of pi over 4 are both the positive square root of 2 over 2. Okay, let's pop these values in. Okay, so I've got the sine of 5 pi over 3. Okay, the sine of 5 pi over 3 is negative square root of 3 over 2. And then I've got to multiply that by the cosine of pi over 4, which is the square root of 2 over 2. All right, and then I'm subtracting the cosine of 5 pi over 3, which is 1/2. And that's being multiplied by the sine of pi over 4, which is the square root of 2 over 2. Okay, I've plugged everything in. Now I need to simplify. Okay, this first pair of fractions that we're multiplying, we're just going to go across the top and across the bottom. We have negative times positive. That will give us negative. Square root of 3 times the square root of 2 is the square root of 6. 2 times 2 times 2 is 4. Okay, we're subtracting. Okay, positive times positive. So go across the top, 1 times the square root of 2 is the square root of 2. Across the bottom, 2 times 2 is 4. Okay, so we can leave the answer like this, or we can factor out a negative 1/4. Okay, and that will leave us with the square root of 6 plus the square root of 2. Okay, either way you want to write it is correct. And now we can go check ourselves on the calculator. Okay, we need to compare the decimal expansions. So we were computing the sine of 17 pi over 12. So let's punch that in. Sine of 17 pi over 12. Okay, there's the decimal expansion. Okay, our answer for the exact value, we got negative square root of 6 over 4 minus the square root of 2 over 4. Okay, so let's punch that in so we can compare negative square root of 6 divided by 4 minus the square root of 2 over 4. We got it right. Okay, so let's keep practicing. All right, let's jump to the top of page 3 in example D. We're going to do the tangent of 15 degrees now. Okay, so yay, we're back to degrees. That's always easier as far as coming up with the two angles you need to add or subtract. Okay, 15 degrees. Okay, immediately I think 45 degrees and 30 degrees. Okay, but again, you can use any combination of angles as long as they add or subtract to be 15 degrees. Okay, I'm going to say this is the tangent of 45 degrees minus 30 degrees. Okay, all right, so we need to go to our formulas, our sum and difference formulas. We have a tangent formula and we're subtracting, so it's going to be the difference formula for tangent. Okay, so if we go back to page 1, okay, if I look at these formulas in the box, this is going to match up with formula number 6, okay, where you have tangent of A minus B. Okay, so I'm going to go ahead and write this down. Okay, we have the tangent of A minus B. Okay, if you go back and copy that formula down, this is going to be the tangent of A minus the tangent of B all over 1 plus the tangent of A times the tangent of B. That's what we're going to be using here. Okay, so if you match up the left sides here, okay, our A value is going to be 45 degrees. Our B value is going to be 30 degrees, positive 30 degrees. Remember, the subtraction sign is taken care of by the formula. Okay, the order of subtraction matters. Okay, so 45 degrees has to be the A value, 30 degrees has to be the B value. Okay, so we're going to plug all of this in. Okay, we want the tangent of 15 degrees. which is the same thing as the tangent of 45 degrees minus 30 degrees. Plug into our red formula. This is going to be the tangent of 45 degrees minus the tangent of 30 degrees, all over 1 plus the tangent of 45 degrees times the tangent of 30 degrees. Okay, so let's go get these guys. We need to look at 45 degrees and 30 degrees. Okay, 45 degrees is the most popular angle ever. Okay, we already have the sine and the cosine for it, but we need the tangent. Okay, so for the tangent, remember, all you have to do, you can do sine over cosine, okay, which you could also do the y coordinate divided by the x coordinate, okay. So the tangent of 45 degrees is going to be the y coordinate over the x coordinate. So you're basically dividing square root of 2 over 2 by itself. Anything divided by itself is 1. So the tangent of 45 degrees is 1. Okay, let me erase this stuff. Okay, now we're going to look at 30 degrees. Okay, so 30 degrees is right here, very close by. Okay, we need the tangent of 30 degrees. Okay, so I'll put that over here. The tangent of 30 degrees. Okay, we need to do the y coordinate divided by the x coordinate. So this is going to be 1/2 over the square root of 3 over 2. This is going to be 1/2 times 2 over the square root of 3. The 2's are going to cancel, leaving me with 1 over the square root of 3. Rationalize the denominator. I'm going to get that the tangent of 30 degrees is the square root of 3 over 3. Okay, so we got to plug in these values. Okay, tangent of 30 degrees is the square root of 3 over 3. The tangent of 45 degrees is 1. All right, so let's go plug it in. Okay, so the tangent of 45 degrees is 1. So we're going to have 1 minus the tangent of 30 degrees is the square root of 3 over 3. In the bottom, we're going to have 1 plus 1 times the square root of 3 over 3. Okay, so let me fix this up here to make it clearer. Okay, so, oops, sorry. Hello. I had it right. Okay, one more time. Tangent of 45 degrees is 1. We're subtracting tangent of 30, which is the square root of 3 over 3. Okay, and then in the bottom, we have 1 plus 1 times the square root of 3 over 3. Okay, we do need to simplify this. Okay, the numerator, well, yeah, the numerator is 1 minus the square root of 3 over 3. Okay, and then the bottom is 1 plus the square root of 3 over 3. This is a complex fraction. We have a fraction within a fraction. So what we can do to eliminate that situation, okay, is we can get a common denominator. There's a couple of things we can do. We can get a common denominator in the top and a common denominator in the bottom. I'm going to continue this on the next page because I'm out of room. Okay. Why am I still going here? And the reason is because, your answers have to be quote unquote simplified. Okay. So we've got 1 minus the square root of 3 over 3. We're dividing that by 1 plus the square root of 3 over 3. And we're trying to get this in a simpler format. Okay. All right. So I'm going to work in the numerator here. Okay. I'm going to make this 1 over 1. Okay, so a fraction minus a fraction. So we need a common denominator. Okay, 1 times 3 is 3. So we need to subtract 2 fractions over 3. The second fraction is already over 3, so we're good. We can just write the numerator. The first fraction, the denominator needs to be 3. So we need to multiply by 3. If we do it to the bottom, we need to do it to the top. So we're going to have 3 over 3, which is 1. Okay, do the same thing to the bottom. The common denominator needs to be 3. 1 is the same thing as 3 over 3. So 3 over 3 plus the square root of 3 over 3. Okay, so now we can add or subtract our fractions. In the numerator, okay, what we have is 3. In the denominator, we're dealing with the denominator of the numerator. So the bottom will be 3, and then we just subtract across the top. In the denominator of the denominator is 3, and then we just add across the top. Okay, so then at this point, we can divide the fractions. I have one fraction divided by another. Simplifying sometimes is the worst part. Okay, so I'm going to write down 3 minus the square root of 3 over 3. Change division to multiplication, flip the bottom fraction. Okay, the 3's are going to cancel because you have one in the top and one in the bottom. Okay, this is going to leave us with 3 minus the square root of 3 over 3 plus the square root of 3. And boo-hoo, we're still not done because we have a radical in the bottom. So we have to rationalize the denominator. Okay, so yay, what do you do in this case? Well, what I'm going to multiply by, because I've actually got more than just a radical in the bottom, I've got this whole expression. So you're going to multiply by the conjugate, okay, of the denominator, okay? So see the denominator, you have a 3 on the left and a square root of 3 on the right. Okay, so I'm going to put that in the top and the bottom in the same order, and I'm going to change the sign. Okay, so instead of plus, I'm going to have minus. Okay, this is what's going to get rid of the radical, as fun as this is. So now we've got to multiply. Okay, so we've got to multiply across the top and across the bottom. Okay, so you're going to have to distribute or FOIL. Boo! All right, so let's do this. Okay, so I'm going to start in the numerator. Okay, I'm just going to do the FOIL process. If you want to box it, that's fine. Okay, so I'm going to do 3 times 3 is going to give me 9. And then I'm going to do the outer terms. 3 times negative square root of 3 is going to be minus 3 square root of 3. The inner terms, we have another 3 times negative square root of 3. That's going to be minus 3 square root of 3. And then we multiply the last terms together. Negative times negative will turn positive. The square root of 3 times the square root of 3 is 3. Okay, so that's what happens to the numerator. Okay, the denominator, FOIL again. The first terms, 3 times 3 is 9. The outer terms, 3 times negative square root of 3 is going to be minus 3 square root of 3. The inner terms, okay, 3 times the square root of 3 is going to give us a positive 3 square root of 3. And then the last terms, 3 times negative 3, or sorry, positive square root of 3 minus the square root of 3. Square root of 3 times negative square root of 3. Positive times negative will be negative. Square root of 3 times the square root of 3 is going to be 3. Okay. So the reason we did this conjugate thing, if you look in the denominator, negative square root of 3 cancels with positive square root of 3. Okay, so the denominator is just going to be 9 minus 3, which is 6. And then in the top, we can combine our numbers. 9 plus 3 is 12. Those guys don't have radicals. Then we can combine the radical pieces. Okay, both of these are square roots of 3. They're like terms because they have the same radical. Just add the numbers in front. Negative 3 plus negative 3 is negative 6 times the square root of 3. Okay, so this is looking better. And then we can go one step further. Okay, we can take each number in the top and divide by the denominator. This is going to be 12 divided by 6, minus sign in the middle, 6 square root of 3 divided by 6. So you have to take each term in the top and divide by the denominator. So the final answer finally is going to be 2 minus, the 6's will cancel here. So it's going to be 2 minus the square root of 3. Okay, here is the answer. I'm going to go to the calculator and rejoice if I have this correct, okay? Because this was a lot of work, okay? I'm going to go in first, and I'm going to just go ahead and do 2 minus the square root of 3 because that's what I have pulled up, okay? And now I need to compare this decimal expansion to what I was computing, okay? Remember, all of this work was to get the tangent of 15 degrees, okay? So I've got to go back to degree mode because I'm in radian mode. So I need to go into mode and hit degree. And then I can punch in the tangent of 15 degrees. And yes, it is right. I was going to be very upset if that was not right. All right, let's try one more.